We are back at it with another Peterson podcast, and I'm not alone this time. I'm actually here with Mama Kitty. Kitty, there you are. Yeah. Oh, and look who heard. Stella. Hi, Stella. Me, Mama Kitty, and Stella. What we're going to do is just kind of review real briefly how to calculate density. Now, I know you know how to do density, but we're going to show you how to do some kind of trick problems in density. So, first of all, make sure you have this worksheet. The first 5 problems, and probably even, I'm looking at it now, the first 6 problems are pretty conventional. You're given either the mass and the volume and you find the density, or you're given the density and you find the mass, or you're given the volume, you're given the density and mass and you find the volume. But they're all revolving around this triangle. I'm zooming in. This triangle like this. Where the density equals the mass divided by the volume. Okay, so if they're next to each other, you're multiplying, and this implies a fraction bar. So let's look at the first example. Example in the box there. What is the density of oil if its mass is 16 grams and its volume is 4 milliliters? So the first thing you want to do, following the 3-step method like we talked about, is write out that M equals 16 grams. Don't forget to put the G for grams. Got to label the numbers everywhere. V stands for volume. We said there were 4 milliliters, so you write 4. Don't forget the ml for milliliters. So that's your first step right here. Second step, density, or D, equals M divided by V. And then you plug in your values. So in place of the M, put what M actually equals, 16 grams. See, you wrote it right there. And what is the milliliter? What's the volume? It's 4 milliliters, just like we said, 4 milliliters. And then when you divide 16 grams by 4 milliliters, you get 16 divided by 4 is 4. And look, a gram divided by a milliliter is simply a gram divided by a milliliter. That's how you label your answer. So, the first 6 problems are pretty much done that way. Sometimes you've got to multiply, sometimes you've got to divide. It just depends on what the triangle calls for. So what I'd like you to do in the next few minutes is try numbers 1 through 6. Okay? You try numbers 1 through 6, and you know, if you can't do it, you're like, oh, I have no idea what to do. Well, then at least write out your information. Say, oh, 125 grams, that's the mass. Then go ahead and write M equals 125 grams. Oh, volume is 5.0 mils. Then write out V equals 5.0 mils. And then it says, what's the density? Well, I bet if you wrote out this bit of information, you could figure out the density is just mass divided by volume. So you write right here, right? D equals M divided by V. Well, if you get that far, it's just a matter of plugging in the numbers you wrote in the first place. So, give it a try, numbers 1 through 6. It'd be a good time to pause the video, and then I'll talk about numbers 7 through 9. So, this brings us to number 7, which looks like an impossibly difficult question. It's very simple, but you're like, how am I supposed to know this? What is the density of water at 25.0 degrees Celsius at room temperature? Now, you could probably Google that, and you would get an answer. Or we could go on to number 8 and actually solve number 8, and we can see what the density is, because we are actually talking about a water sample at 25 degrees Celsius. We know the volume is 92 mils, and we know the mass is 92 grams. So let's start by writing that information. I'm going to zoom in so I can write. So we know volume is 92. Volume is 92 milliliters. And then we said the mass is 92 grams. And we should put the temperature is 25 degrees Celsius. That doesn't really factor into our equation, but we're going to talk about the same sample of water at a higher temperature here in a moment. So, what's the density? Density is mass divided by volume. So let's plug in our values now. We know the mass is 92 grams. We know the volume is 92 milliliters. And so we get 92 divided by 92 is 1. For sig figs, though, I'm going to call it 1.0. I got 2 sig figs in my answer because I have 2 sig figs in 92. And then I've got grams divided by mils, so I write grams divided by milliliters. So it turns out that the density of water at 25 degrees Celsius, room temperature, is 1 gram per mil. And we actually saw that on the first lab we did in this class back with the milk cartons. We were measuring how many mils were in the milk carton, how many grams of water was in the milk carton. And when you guys divided those to find that relationship, it was usually a number really close to 1. Sometimes it was 1.01 or 1.1 or 0.9, but the point is it was really close to 1. And that's the density of water at room temperature. Okay, so that's at room temperature, but what happens when you heat the same sample of water up to 99 degrees Celsius? Well, the amount of water doesn't really change. In other words, it's still going to be 92 grams, and I'm quickly running out of space, so I'm going to just do my calculations down here at number 9. So let me just refresh my memory. We're talking about 99 degrees Celsius. So at 99 degrees Celsius, that's our temperature. We still have a mass of 92. But the volume has changed. See, it's the same amount of water. The mass is still the same. It's not any heavier just because we heated it up, but it does take up more space. And so now it's 99 milliliters. It's the bigger volume. Most things tend to expand when you heat them up like that. Okay, so now let's calculate our density. So we still have density equals mass over volume, only this time, instead of 92 over 92, we get 92 over 99. And these are grams and these are mils. So our density equals, so when I divide 92 by 99, I get 0.929292 repeating, and that I'm just going to round to 2 sig figs, so it'll be 0.93, and check it out, I've got grams over milliliters, and so I label my answer grams divided by milliliters. So that's my final answer for the warmer temperature. So I kind of ran out of room, so I had to go into number 9. So then it says, number 9, usually when water is warm, it expands to take up more volume. How would this affect the density? If you're not sure, consider your answer in the previous question. So how does it affect the density? When it was colder water, right here, the cooler temperature had a density of 1, and the warmer temperature had a density of 0.93. So I'll let you answer number 9. So that pretty much ends our Peterson podcast for tonight. Mama Kitty's looking pretty hungry though, and she's learned that anytime there's a bell, there is a kitty treat not far behind. You want a kitty treat? And Stella knows that she gets a doggy treat. You want a cookie, Stella? Yeah, I'll get you a cookie. Ready? Oh, you missed. That was for posterity, too.